Erupting volcanoes are among the most dangerous and spectacular events in the natural world. If one explodes on your doorstep, who do you call?
Looking at these rocks on a beach, it's really very exciting because I can tell a story about a little fragment of Earth's history 300 million years ago.
Professor Steve Sparks is one of the world's leading volcanologists. His expertise gives him a very special ability to read the landscape.
The white rocks just below me are full of shell fragments and bits of coral, so I know that these rocks formed on a warm equatorial shallow sea somewhere on a quite different part of the globe 300 million years ago. And over there's a series of green rocks which represent volcanic ash deposits from a volcano which suddenly went off in this shallow sea, and there must have been really serious explosions near here, producing layers of volcanic ash which landed on the sea floor. I can now go over to these rocks, massive rocks here, and by making observations I can tell that this was a red-hot lava which flowed slowly over the sea floor at temperatures of probably 1,200 degrees centigrade. So there must have been really a substantial volcanic eruption. And now we're at the top of the lava, and what we observe are a lot of white blobs near the top. And when I look at these, I realise that these are in fact big bubbles of volcanic gas, bubbles that have floated up through the liquid lava to the top. Not only can I tell that it was a lava because these are bubbles, but I can also say something about how long it took the liquid lava to turn to solid rock, because it takes a certain amount of time for a bubble to float up to the top.
When Steve began studying volcanoes, little was known about the physics of how they worked. When a major eruption took place in Iceland in 1973, Steve and fellow geologist Steve Self immediately took the opportunity to go and have a look.
It was pretty fantastic, really, wasn't it? I remember we went across on a tiny little boat in the middle of January in Iceland. We saw this new mountain coming out of the ground, essentially, with these huge, spectacular firework display. Right. And it was really an incredible situation to see for the first time a real volcanic eruption.
Yes, and this sort of jetting noise all the time from the magma shooting out of the vent.
There were earthquakes going on, so when we were sleeping at night, you could feel occasionally the ground vibrating from the earthquakes. We occasionally got too close to the volcano because when the explosions took place, they got lumps of red-hot lava being ejected.
Walking around with the ash raining down on you, and you can hear it pitter-pattering on the roofs and onto the hood of your anorak and everything.
It was quite a surreal situation because parts of the town were actually already buried. You could see roofs sticking out.
And you could see the tops of road signs just at your feet level, so you knew how thick the ash had accumulated already in parts of town.
Was it scary?
I can't remember being scared, can you? It's just such a fascinating, awe-inspiring sight to see I guess one of the great spectacles of nature going on. Really these massive fountains of red-hot lava being thrown out of the volcano. It's really quite an incredible sight. That was certainly a seminal experience, seeing a big eruption for the first time, and I suppose it really instilled in us both a desire to go on and develop curiosity-driven research, just find out why things happen, why volcanoes erupt in the way they do.
These two young geologists were among the first people to study volcanoes in a scientific way. They began by making simple measurements as the eruption was happening. This got them thinking about the forces that give rise to volcanic activity. But Steve's curiosity about the Earth's history began a long way from Iceland.
When I was a teenager, I used to wander around North Wales, mountain climbing and sometimes going down potholes. And I started to pick up minerals and fossils, and I found those interesting and beautiful to look at. I didn't think at the time I was going to be a geologist. When I was at school, I started to learn about volcanoes in my geography classes, so I suppose it aroused my curiosity in the history of the Earth.
To get very close to lava flows, Steve sometimes has to wear a special silver suit to reflect the intense heat. But that's not all he does.
Studying volcanoes is a lot more than running around in silver suits. In actual fact, most of the time one is a lot further from the volcano and observing it in perfectly normal clothes. A lot of the work involves studying the laboratory, doing experiments, doing calculations on computers.
Steve started to think about why some volcanoes produce relatively harmless lava flows like this, while others explode violently. His research led him to an unexpected subject: the physics of bubbles.
This rock in front of me is very interesting. If I pick it up, I find that it's incredibly light. It's a volcanic rock, a lump of pumice from a big explosion in New Zealand. And the reason it's so light is it's absolutely full of bubbles. And bubbles are really very important to understanding how volcanoes work. Now, volcanoes either produce lava or they explode. Down deep in the Earth, the magma has gases dissolved in it, and as the magma comes up to the Earth's surface and the pressure goes down, bubbles start to grow. Now, if the magma comes up quite slowly, the bubbles can easily escape from the magma and the magma erupts as lava without any problem. If the magma comes up very fast or the magma is very gooey and stiff, then the bubbles have a great deal of difficulty escaping, and in fact they come up to the Earth's surface with very high pressures, and that makes the magma explode and we get a big volcanic explosion. One of the problems with the volcano is we can't go down into it, particularly when it's erupting explosively. So the next best thing is to go to the laboratory and try and simulate what's happening with some simple experiments. Now, in this experiment we've got some pine resin with some gases dissolved in it under pressure. So it's just like a magma chamber, really. And what happens is the pressure is relieved, just like it's in a volcano, and the gas in the pine resin expands explosively and rushes up the tube towards the surface in an explosive eruption. So in this way we can actually simulate and understand what's going on inside the volcano.
3, 2, 1.
As a scientist, I have to understand some of the physics behind the way bubbles move through liquids, and to do that I have to know a bit of maths. And so a lot of my work has actually been involved in understanding the mathematics of how, or the mathematical description of how bubbles grow, how they produce high pressures, and how they can produce volcanic explosions.
But what about out of hours? Does Steve still have volcanoes on his mind when he's at home?
Whew, it's hot out there. Guess I could do with a cup of tea. Got married as soon as we finished our degrees.
Yeah.
Yes, 1971.
So that was the start of quite a long
I
relationship.
took you up, well, not exactly a volcano, but I took you to North Wales for our honeymoon, didn't I?
Yes.
That's right, and we walked around staring
challenged me. You know, Steve has always been challenging me since the time we met. He'd sort of say, "Oh, we can climb up this sort of vertical thing." I said, "No, I can't do that," you know. And he'd say, "Well, yes." So he'd just sort of guide me up, and I'd be up at the top of this rock face, and life has never looked back really.
And you came, when I was doing my PhD in Italy, you came along with me and we went up. I think that's the first volcano we climbed up Mount Stromboli.
Oh, Strombley, Mount Etna.
And we went to Etna.
Yeah, and we went out to Pantaleria as well.
That's right, yes. So we saw some volcanoes there. And
yeah, so this was all one summer as soon as we were married. Very, very exciting, great fun.
But it's not always fun. In July 1995, the volcano on the small Caribbean island of Montserrat erupted violently, killing 19 people and displacing thousands. Steve dropped everything to become the island's chief scientist, making him responsible for deciding which parts of the island had to be evacuated and when. Steve's wife Anne joined him on the island.
Yeah, that's a very good experience for me because it gave me some understanding of what Steve's work is all about. I'd argued with him a lot over the years. What is the use of what you're doing? Because I'm a much more practical person, much more of a doer. For the first time I could see that this has very powerful effects. It's very, very useful. And I could also see that Steve was doing a tremendous job.
Did you ever get worried about Steve getting caught up in the lava flow or something?
Not really, because I do believe he has a very good understanding of the volcanoes. I don't think he'd take risks unnecessarily.
well, not too many anyway.
Well,
yes.
well, I'm not there to see, so that's all right. Yeah.
Didn't you bring back some mementos though?
Oh yes, we brought back a lot of rocks, but this is I think perhaps a rather favourite. This was a bottle of Carib beer, something I guess all the scientists got used to the shape of bottles of Carib beer during the eruption. But this is what happened when a bottle of Carib beer got enveloped into a pyroclastic flow at the airport. It basically melted, and that tells me that this has been up to about 400 degrees centigrade to melt. So it shows how hot and deadly the pyroclastic flows are. So there's a couple of mementos from the eruption.
Instead of liquid lava, the volcano in Montserrat produces pyroclastic flows, deadly avalanches of hot ash which sweep down the mountainsides, burying everything in their path. To help predict how these pyroclastic flows will behave, Steve undertook further experiments in his lab in Bristol.
3, 2, 1.
So this is just like a volcano. The particles force themselves out of the volcano and we get a beautiful fountain. The material falls under gravity, jetted out of the volcano or our experimental volcano, and then it starts to spread across the ground. It's a beautiful current. And you can see the current that's moving across the tank, and really this on a small scale is just like what happens in the formation of a pyroclastic flow. There's the volcano exploding in the middle, and there's the current or flow spreading across the flanks of the volcano. As the current goes, it's dropping its particles, and then a cloud of very fine particles and water is rising up into the tank. It's just like the cloud that rises off the flows in a real pyroclastic flow eruption, rising high into the atmosphere. Now, of course, after the eruption, a huge amount of fine volcanic ash is in the atmosphere, just as you can see in the tank, and this causes basically to go during the daytime. It'll go almost like night. The ash shields the sunlight, and it's a very eerie and a very difficult environment, and the ash gets everywhere, spreads inside houses and across all the ground. In Montserrat, there were quite a lot of explosions and pyroclastic flows, and those ash clouds, if you were in them, basically it was like being at night.
Once the ash has settled, Steve can assess the damage. In the past, such an ashfall could have cost many lives. Now, Steve's models can predict which areas to evacuate. Here, the family seems to have just about got out in time. Of course, Steve doesn't study volcanoes on his own. He has a whole team of researchers working with him.
Hi, my name's Susan and I'm doing experiments growing crystals in magma chambers.
I'm Claire and I'm characterising volcanic ash to assess its potential toxicity.
Hi, my name's John and I'm studying how bubbles form and grow to cause explosive volcanic eruptions.
Hi, my name is Costanza and I study volcanic ash and try to predict how fallout works.
Why did you get interested in volcanoes though? What was it that got you interested?
I think because in Italy there's so many volcanoes that they're always on the news because Etna explodes every like 3 years, 2 years. So we always see volcanic activities on television, and this is why I became fascinated.
So how do you know what's going to happen to ash when it explodes?
First of all, we do field work in order to collect enough field data, and then you use this field data to compile computer models, and then we can use these computer models to simulate eruptions, and so we can predict where ash will fall, and then you can say, okay, these areas are safer than others, for example, so it's fine for people to live there or not.
And volcanoes are quite exciting.
Oh,
Is it ever dangerous?
Yeah, it can get dangerous, but as long as you're careful, it's fine. So no, it's good. I mean, it's very exciting because obviously you go there, and for example, when I've been to Montserrat, which is active at the moment, you can actually see the real eruption instead of just working on old observations and just reading papers. You actually go there, you see it, and then you can understand it better, because if you only see on paper, you can't actually understand the process too well. So it's really good that you can go there and see how it all works.
One of the things that a geologist does is to try and puzzle out the clues that are in the rocks, and trying to puzzle out what that means for the processes that go on in the Earth is a lot of fun. It's a bit like being a detective. You've got these little bits of clues that you have. You don't have all the information you need, and you have to puzzle out what happened from looking at these clues. And when you solve the puzzle, that's very satisfying. When I was a teenager and we used to walk around these mountains, of course I had no idea that they contained a fantastic record of the history of this part of Britain. About 450 million years ago, this area was in fact one huge volcano, as big as the biggest volcanoes we have on the Earth today. And there were colossal eruptions, and so the landscape was created by these enormous volcanic eruptions. This is Tryfyn, one of my favourite mountains. It's amazing to think that it's made of volcanic rock from an eruption which is about 1 million times bigger than the biggest eruption we had on Montserrat a few years ago. Volcanoes are important because they're actually a manifestation of the fact that we are on a very dynamic planet, and that's why we have life on Earth, and why the oceans, the landscape, the mountains are so varied, is because we're on a dynamic planet. Sooner or later we're going to get one of these really super volcanic eruptions. It may not, maybe next week, it could be in several thousand years from now, but it'll happen. We're still not very good at forecasting when volcanoes are going to erupt and where they're going to erupt. There's going to be many, many decades of exciting research to do before we're in a good position to answer those questions.